Okay, good afternoon, everyone, and welcome back. Please note that the class is now being recorded. We're going to be starting with our lesson. Good afternoon, everyone, and I'd like to welcome you back again to our online classes. Please note that the class is already now being recorded, and I also have got a backup recording which is going to be running on my side. So today we're going to be starting with lesson 11, which I believe some of you have managed to do the pre-reading if you managed to see the slides which were already uploaded. And previously we did do the practical question. To those who didn't come to class, I'll start by making an announcement of what I did mention during the Friday class, which is that there is going to be new changes in terms of your summative assessment. You are going to write a summative assessment, which is no longer going to be a closed book, but an open book one, meaning that you will be allowed to bring your textbook in when you write the summative assessment. But all the other rules will still be the same. So just that part, and that also you'll also be given an assignment by the end of the semester for those who are not aware of that. So with that being said, let's start with our lesson for today, which is going to be talking more of equations and formulas. So here we've got the links that are available for you guys to be able to go through them and watch the pre-recorded lessons that have been done by other people. That will give you also another overview or understanding of the concept. So you can either watch the recordings before you come to class or after the class, which will still make you become better or become better to understand the topic itself. So today's lesson will be covering page 120 to 140 of the textbook, which is our finance in media. And as regularly, this is what you always have to do each and every week during the academic period. Attend your classes on time, participate on the engagement that we do in class, participate on online discussion forums, and the most important, completing the textbook activities covered in the lesson. Each and every time I always mention some of the activities that you need to cover, so please make sure that you cover them. So today's lesson is a continuation of chapter 2. So we're just moving forward with chapter 2, and today's lesson outcome as well with lesson plans and the lesson outline was that you should be able to understand equation, simplify and solving equation, understand formulas, and then explaining the difference between independent and dependent variable. And then lastly, we'll be doing linear equation and calculating linear equation in a business setup. So equations, let's start with an equation. So an equation here, based on the presentation, it says that it is a mathematical statement with an equal to symbol between two expressions that have got equal value. So this just means that when we are working with equation, we're going to be having expression from one side and the other expression on the other side. But most of the time you find that there is only an expression on one side. On the other side, there is just only what we call a constant or just a single number. So equation we only get to identify equation when there is an equal sign in between the expression, between the left expression and the right expression, and meaning that whatever is on the left, when solved or when added or calculated, have to equal what is on the right. So previously we did an equation which was called the accounting equation earlier on in lesson 2. We introduced the Sorry, I'll just have to mute someone whose mic is a bit on. Okay, done. So I was busy explaining that based on the equation, we have covered one of the concept, which is the equation back then in lesson 2, which is the accounting equation. If you still remember under the accounting equation, I did mention that whatever is on the asset side should equal what is on the owner's equity and liability side. And we did perform a number of activity to also prove that for an equation to exist, therefore there have to be an equal sign, and whatever you do on the left side is supposed to be equal to what is on the right side. And if it is not equal, therefore it won't be classified as an equation. So an equation is something that have to be proven first to make sure that whatever you do on the left side is equal on the right side. So here it shows that it continues to read that it shows the relationship of equality between the expression written on the left side and the expression written on the right side. An example will be 5 plus 9 equals to 9, but an accounting or finance example will be the accounting equation, where your assets will be equal to your owner's equity plus liability. And then when it comes to equations, this is how you get to identify an equation. The first step is that it have to have an equal sign. So the equal sign doesn't have to, there's no specification on where the equal sign should be, but there should be an expression. If there is no expression, then there is no equation. So first thing is that we need to have an expression and an equal sign. So then we can have what we call an equation. But if we just have an expression without an equal sign, we can have a greater sign to say that this expression is greater than 4, meaning that that's no longer an expression, that's no longer an equation, but will only qualifies it as a full expression or a statement, which you'll either have to identify whether this is true or false. But in equation, you will have to prove that whatever is written on the left will be equal to what is on the right. So here we've got example of types of expression that some of them have been identified to be an equation, where we've got y equals to 8x minus 9 because of the equal sign and the expression, which is x 8x minus 9, which is an expression, and this side we've got what we call a constant or just a value. So and then we've got our equal sign in between. So this qualifies this full expression to become what? An equation. Because once we prove the value of x and we prove the value of y, therefore this will qualify it to become what? An equation, meaning that whatever value of y has to be there, and once we find the value of x and we replace it, both of these sides have to become equal. And on the second one, you will notice that we do not actually have an equal sign, but we have y plus x squared minus 7. So this will not become an equation until there is an equal sign. If we put an equal sign and say 0, so this will qualify it to be an equation, because now we are saying that everything on the left side will equal something that is on the right side, which is 0, meaning that the value of x and y, once found, they will add up and we're going to get a final answer being 0. And then on the last one, we've got 7 plus 2 equals to 10 minus 1. So we've got two expressions here. The first expression on the left side, the second expression on the right side. And then we've got an equal sign in between. So therefore, this qualifies it to be what we call an equation. So there are a lot of equations that are available out there, which we can actually play around. So this is a full elaboration of how an equation is. So under an equation, we've got terms that are used, and we've got the expression that also have its own values, or we've got items that also have got their own explanation. For example, when you have got an expression that looks like this, so this expression have got what we call a coefficient, variable, an operator, and a constant. So the operators on each and every expression, we only have got 4 basic operation. We have also covered this during the lesson where we're doing fraction with 4 basic operation, which are addition, subtraction, multiplication, and division. So those are operators. So those are the 4 basic operators within mathematics and finance. So we use all of those. And then when you have got a variable, so normally a variable will be a symbol representing the value that is not yet known. And then the coefficient will be the value that is multiplying the variable. And then any value that is do not have what we call a variable will be represented as a constant, meaning that that value will not get to change. Because the value of 2x will actually change, therefore we're going to have a variable and a coefficient to actually find what is the value of these two, which will become the new constant. So until then, we're going to have a variable and a coefficient. So a coefficient is the number that is multiplying the variable, which is a value that is not known within the equation. And then the other side, we have got a constant, and meaning that this is not an expression but a constant alone. So therefore, if we have got 2x plus 9 equals to 24, we only have one expression and a value on the other side, which is a constant. So when moving forward, normally I'll be referring to these as a coefficient and variable. So is there anyone who have got any questions so far? Anyone? Please do not forget to raise your hand if you have got a question. I've got another device open on my side to make sure that I'm able to identify if you have raised your hand or if you have got any questions. So you can just raise your hand during the lesson. I'll be able to still see your raised hand, and then I'll give you the mic or the opportunity to ask. So with just that in mind, I'm just going to switch to the textbook. And then from the textbook, I'm going to be explaining the method of actually simplifying or solving an equation, which is from this part. So I'm just going to explain it from here, and we're going to go to the textbook. And from the textbook, we're going to work through solutions step by step, following all these methods that I use to solve an equation. So an equation can be identified anywhere and can be used anywhere to actually try to solve a problem where either money is involved or numbers are involved. So here there are 5 basic rules. So some of these basic rules we have been applying them, but without knowing that we are following all of these steps that have been mentioned here. So the first step to solving an equation is that the same number may be added to both sides of the equation. So when do we perform this? If we have got an expression or an equation that looks like the one that I just mentioned earlier, 2x plus 9 equals to 24. So when you have got one number on the other side of an equation and that number is negative, to eliminate that number, you will have to add the same number on both sides. So meaning that on the other side, we'll actually be cancelling the other one. So that is the first step. And if the number is positive, then we follow the second rule, which says that the same number may be subtracted from both sides of the equation, meaning that on the other one where it's adding, once we subtract it, it's going to cancel each other and only left be with the one on the other side. And then the third one says that both sides may be multiplied by the same number, but not a number that is 0. So we cannot use 0, we can only use numbers that are above 0 or below 0, which are our integers, the negatives. So therefore, meaning that when we only get to multiply, it means that whatever is there on our equation, it must be dividing. So if we've got a value dividing another one, and want to transfer that value dividing the other one to the other side, we do the multiplication. And when we've got a value that is multiplying another one, for example, we want to try to leave the variable on one side and get all the numbers to one side. So meaning that when we try to get the variable on one side, we are actually going to get to divide the number that is multiplying the variable with that number, and we do it on the other side, and that number will cancel each other. And the last one is to apply the distributive law if we've got brackets within our equation. So the distribution law says that if we've got a number multiplying, if we've got a number outside the brackets and we've got an expression inside the brackets, that number will multiply everything that is inside that bracket. An example is as follows: a multiplying in brackets x plus y. So this can still be expressed as ax plus ay, meaning that a will have been multiplying x, and again a will also be multiplying y. And given the value of those, if they are both negative, therefore the sign will change to positive, and if one is positive, one is negative, the sign will still be the negative. because we're going to be applying that mathematics rules. So what I'm saying now based on all of this is the following. If you remember, we did what we call the BODMAS. So on the BODMAS, we went and say when we reach the multiplication and division under the BODMAS rule, we say the division and multiplication hold the same, they have got the same strength in terms of the mathematical rules. And we also went and said that addition and subtraction hold the same rules. So meaning that if we were to cancel the division, we're gonna use multiplication. If we were to cancel multiplication, we're gonna use division. Then same applies when we want to cancel a negative. You're gonna use a positive. So you're gonna be applying the opposite. So based on the textbook, I'm just gonna quickly go to the textbook. So here we are. So on the textbook, we're gonna start by taking a look at rule number 1. So rule number 1 says that the same number may be added to both sides of the equation. So everything that I just explained earlier on will just come into existence, and you'll be able to pick up why I was saying that. So we've got the first equation being x minus 3 equals to 6. So if we were to solve this equation, we would want the constant or the variable to remain on this side and solve whatever is going to be on the right so that we can get the value of x. And to do that, since we have got minus 3 on the left side and we're trying to remove this minus 3 from this side to the right side, so what we do is that we're going to add plus 3 on both sides. So meaning that on this side we're going to have minus 3 plus 3, which is going to equals to 0. And therefore on the other side we're going to have 6 plus 3, so meaning that the 3 have now been transferred to the other side. So without applying this, we just use back the basic rule to just say that just change the sign of this and apply it that side. But we are actually applying what we call the method of solving an equation, which is rule number 1, adding the number both sides of the equation, where we're going to have x now being equals to 9. And to prove that this is a real equation, we still have to substitute the 9 onto the x to say that if x is equals to 9, let's prove that both sides of the equation are equal. So we're going to say 9 minus 3. And if we put 9 minus 3 on your calculator, you're going to find the value being equals to 6. So meaning that this is 100% an equation. So if it doesn't add up, that means that it is not right. So meaning that whatever this they are saying that this equation is, it is not correct. So meaning that it is meaning that the whoever wrote this equation made a mistake somewhere else. So we've got equations that have not yet been proven and that cannot be used. So until they are proven, therefore they will not be classified as a full equation, but just as an drafted equation or an expression. So an equation is something that you can actually get to prove. For example, assets equals to owner's equity plus liability. So we proved that by recording all transactions that are occurring within the business. And we notice that whatever we record there within that accounting equation, at the end, everything balances. Our assets will always be equals to our owner's equity plus liability. And then the second rule is that the same number may be subtracted. So it is not, these all rules are not saying that you have to apply them all the time. You only apply most of these rules depending on what the scenario is based on or what the equation is saying. For example, the second equation says x plus 9 equals to 14. So when x plus 9 is equal to 14, so we've got a positive 9 this side, and when we're trying to solve for x, we'll want x to be on one side. So when one want to leave x alone, what we normally do is that since this is positive, so therefore we're gonna subtract 9 on both sides. And once we do that, this will cancel the positive 9 on the left side, and therefore 9 will be transferred on the right side and it will be having a negative sign. So therefore we're gonna have x being equals to 14 minus 9. And then once we calculate 14 minus 9 will be 5. So meaning that we can try to prove this by saying 5 plus 9, and then it will be equal to 14. So therefore this is a full equation and a true equation. And then if you remember, I said that where there is division we use multiplication, and where there is multiplication we use division. So this is the simplification method that I can explain to you in terms of rule number 3 and 4. And for rule number 2 and 1, it means that where there is a minus you use a positive, where there is a positive you use a negative of that same value to actually transfer it to the other side. So you either add it or subtract it depending on the value of from the original equation. So on rule number 3 it says that both sides of the equation may be multiplied by the same number, but the number have to be a non-zero number. So meaning that you cannot multiply by 0. Reason behind that is that if you multiply any number by 0, the final answer will be 0. So therefore 0 cannot be used to transfer any amount or to simplify or solve an equation. So on this one we're going to be having x over 5 multiplied by 4. So under this expression, we are actually applying what the fraction rules. If you still remember the fraction rules, to say that now we've got a division, x divided by 5, which is equals to 4. So to transfer this to the other side, we are saying that we're going to multiply everything by 5 to cancel the division. And therefore, once we do that, we're going to have x over 5 multiplied by 5 equals to 4 multiplied by 5. But based on the mathematical rule, every number is already divided by 1, meaning that that number, even if it's divided by 1, will become that number. For example, here we've got a fraction x over 5, and then we've got multiplied by 5. So this 5 is already divided by 1. So since it's already divided by 1, we can use the fraction rule to say that if you are multiplying within the fraction, multiply the numerator with the numerator and the denominator with the denominator. Therefore, we're going to say 5x multiplied by 5, giving us 5x. And then 5 multiplied by 1, which is the one dividing the 5, we're going to have 5. So we're going to end up having 5x divided by 5. And therefore, 5x divided by 5, that's going to give us 1x. And meaning that this number is just 1x. So meaning that the 5, that's how the 5 gets to cancel each other. And from there, we're going to have on the other side 4 multiplied by 5. When we calculate that, it's 20. So x is equals to 20. So that's using multiplication to cancel the division. So that's rule number 3. And you can prove and say 20 divided by 5, that will be equals to 4. And then we're going to move forward to rule number 4. Rule number 4 is where we get to cancel multiplication. So to cancel multiplication, we use a division. For example, on our equation, it says that 7x equals to 73. So we've got a variable that is being multiplied by a coefficient. So to cancel this coefficient that is multiplying the variable, for us to be left with the variable. So what we do is that we're going to divide everything by the coefficient so that we can cancel the multiplication of the variable and coefficient. So once we do that, we're going to have 7x divided by 7 equals to 63 divided by 7. So meaning that 7x divided by 7, that will be equal to x, 1x. So meaning that we're going to have 1x. So normally if it's written like this, it's automatically 1x. So meaning that from there we can calculate 63 divided by 7, and then we're going to have 9. So meaning that x is equals to 9. So if we say 7 multiplied by 9, we're going to get 63. And the last rule is to apply the distributive law to say that if you have got a number multiplying everything in brackets, therefore, and you have got number next to the open brackets, so therefore that number will multiply everything that is inside that bracket, and therefore lastly it can be expressed in a different format. So an example here, we've got 4 inside brackets, 5x minus 4 equals to 24. So to simplify this equation first, we are going to actually express this through the distributive law because it can allow us to apply the distributive law. So what we're gonna do is that we're gonna go and say 4 will multiply 5x, and then 4 again will multiply minus 4. So meaning that we're gonna have 4 multiplying 5x giving us 20x. So this 4 multiplies the coefficient. So the coefficient is attached to x. So if there is any number multiplying the coefficient and the variable, it only multiplies what we call uh, the coefficient. Someone is asking a question. Is the lesson going to be uploaded on campus? Yes, the question will be uploaded, as I did mention earlier on the recording that is being recorded. So let's continue with the lesson. So from there, the 4 again will multiply 4. So meaning that we're going to be having 4 times 4. So 4 times 4 giving us 16. So the 16, therefore, we have to identify. We have got minus 4 multiplied by positive 4. So therefore, the value will still remain as a positive, as a negative. So it's a negative multiplying the positive. So therefore, the value will remain as a negative. And then from there, we've got now another simplified equation, which is 20x minus 16 equals to 24. So therefore, we're going to now try to simplify it based on the rule number 1 and 2. And then from rule number 1 and 2, we're going to check if we can still apply rule number 3 and 4, which one of those. So most of the time, sometimes you find that you only have to apply one rule or two rules or all of the rules, depending on the type of the equation that you're trying to solve. So if you find a distributive equation, it will allow you to at least use the 3 rules or all the 5 rules, including its distributive law within that equation. So under this equation, now I've got 20x minus 16 equals to 24. So from this equation, we can actually then simplify it by going and say, let's leave the variable and the coefficient on one side and transfer the constant to one side, which we can be able to add them together. So we've got minus 16 here. So since we've got minus 16 here, what we're going to do is that we're going to add 16 on both sides to cancel this minus 16 on the left side. So once we do that, the minus 16 on this left side will be cancelled and we'll only be left with 20x on the left side. And on the right side, we're going to now have 24 plus 16, since we have cancelled the negative on the other side with the positive. So we're going to have 24 plus 16. So leading us to 20x equals to 40. Then now we've got only the coefficient multiplying the variable, and we only want to identify the value of the variable. So therefore, since it's multiplying, we're going to use the division. So what we're going to go and do is that we're going to go and say 20x divided by 20. We divide with the same value, which is 20. And then again on the other side, we again divide with the value, which is 20. And therefore, on this side, it's going to cancel itself. 20 will cancel 20. Or it's going to be 20x divided by 20, which is going to give us 1x. And then from the other side, we're going to have 40 divided by 20, which the value will be 2. So meaning that if we substitute this value here by 2, which means that we're going to have a final answer being equal to 24. So if we substitute x by 2, we're going to have 5 multiplied by 2. So 5 multiplied by 2 following the BODMAS rule, we're going to start with the multiplication that is inside the brackets. So it's going to be 5 multiplied by 2 giving us 10. And then from there, we solve everything that is inside the brackets if there are no other operation except the last one, which is the minus. So if we have got division inside, so previously I explained that when you're working with BODMAS, you look for brackets first. Once you find the brackets, try to solve everything that is inside the brackets. And when you're solving all of these things inside the brackets, you still go and apply the BODMAS rule again from scratch to say that inside the brackets, do I have another bracket inside the brackets? This time we're going to have brackets inside the brackets because we'll be replacing x by 2, meaning that we're going to be having 5 multiplied by 2, which is going to give us 10. From there, we'll move to addition. We move from division, we don't have, multiplication, don't have, and then we go to addition, we don't have, and lastly we've got subtraction. So it's going to be saying 10 minus 4 giving us 6. Then from 6 we're going to go and say 6 multiplied by 4, and therefore we're going to now multiply everything that is inside the brackets with what is outside the brackets, which is going to say 4 multiplied by 6, giving us 24. So this is 100% an equation. So an equation based on what we just covered so far. So that is all in terms of drafting an equation and solving an equation and identifying that this is a 100% an equation. So you still need to prove that the left side is equals to the right side, especially if you are solving for a variable which is not known. So any question guys? Okay, can I just see thumbs up if you are all still okay? Guys, are you following? Okay, thank you very much for the thumbs up. So that is all in terms of identifying an equation and the rules that applies to solve an equation. Meaning that to cancel a positive, you use a negative. To cancel a negative, you use a positive. To cancel a division, you use multiplication. And to cancel multiplication, we use division. So these are the four basic rules that you need to understand. The distributive law, then you're going to apply it through the BODMAS rule, which we're already familiar with. And then once you identify an equation becomes what we call a formula once it is tested and become true. We have done an accounting equation on lesson 2. We have recorded information and we did manage to find that every time we record our information on our accounting equation, everything balanced. Our assets always equals to owner's equity plus liability. So therefore that becomes a formula to say that every time whenever you have got transaction within the business, you're gonna apply that same rule, or you're gonna apply or use that equation regularly, meaning that it's no longer now an equation but a formula which gets to be used. So for a formula to exist, there has to be an equation first. So please just give me a minute just to answer something. Okay, and I am back. Thank you very much. So as I was still explaining that for a formula to exist, an equation have to exist first. And once an equation exists, therefore, and it is proven, it becomes what we call a formula, meaning that you can use that repetitively to actually get to solve new problems. So here it says that a formula is a fact or a rule written with a mathematical symbols. It is usually connects two or more quantity with an equal sign. So when you know the value of one quantity, you can find the value of another quantity using the formula. So many problems, many business problems involve the use of formulas. For example, when we're trying to calculate how much money we generated on the business, we use an income statement, and an income statement follows the following formula to say that all the revenue that we have generated minus all the expenses that we incurred, then it will give you what we call profit. So what basically it is to say that in the beginning of the financial year I had 100,000. I went and used the 100,000 either to buy stock and then to pay transportation, everything that you will need to run the business. And then later on, when you sell those goods, you generate revenue and gain income. And then from there, for you to be able to see if you manage to make profit or loss, therefore you're gonna go and say all the money that you received minus all the money that you spent it. And then if the money that you receive is more than the money that you spend it, then we say that you have a profit. And these have been done repetitively and have been proven to find that it is true that profit or loss is equals to revenue minus expenses. So meaning that that equation have been done many times and have been proven. So therefore it become a formula, and therefore we get to use it all the time to solve that type of a business transaction. To say that another example would be to say that You will have your income, which is from your revenue. And under expenses, we've got different types of expenses. We've got your cost of sales, we've got your operating expenses, which is your salaries, wages. So meaning that if, for example, you had that 100,000 and you went and spent it to buy those stocks and pay other things, but there is something that you didn't manage to account for within your business, but you managed to account for all the revenue that you generated. So meaning that, and then you actually know, okay, I had 100,000, I spent all the 100,000, I generated the profit of this much, but there is one expense that I did not account for. So what you do is that you're gonna go and say the money that you had before, that you spent all of it to on expenses, and then you subtract it from your revenue, you're going to have your profit. Then from there, you can use to say that I've got a profit of this much and I've got a revenue of this much. And then when it comes to expense, you will create that what you call an equation, which is going to look something like this. So I'm just going to end the slideshow and write something so that you can be able to see the expression of what it will become. So to say that you're gonna have your amount, let's say it's 150,000, and then you know that so let's say it's 50,000, not 150, so that it suits the scenario that I mentioned. And then your profit, we are saying that you generated 150,000, but for your expenses, we are saying that you spend it 100,000, but you do not know, you have got one item that you don't know where the other money went to. You have accounted for all the expenses, but you do not know how much you spend it on that. So you are going to say open brackets, all the expenses that you incurred, which is for example 50 or 80,000 plus A. So the A will represent the missing figure. For example, if you are working with a larger number. So meaning that now you will have an equation to actually solve for A. And then it will give you the remaining amount. So if you went and solved this, so you're going to end up with 50,000 equals 250 minus 80,000 minus again A. So this minus will multiply everything that is inside the bracket, applying the what we call distributive law. Even though there is nothing here outside, so we refer this that there is a 1 that is multiplying everything that is inside the brackets. So that is the mathematic rules. So meaning that you're gonna be having this end up being as written as this under the distributive law. So we're now using the formula which started as an equation to actually solve a business problem. Then from there, you're going to have what we call 150 minus 80,000. So all of these you're going to calculate with your calculator. And then 150 minus 80,000, you'll be left with 70,000, which is going to be a positive, minus A. And then you're going to transfer, you want to transfer the 70,000 from this side to the other side. And then meaning that since it's positive, we're going to cancel it through the negative. So when it comes this side, it's going to say minus 70,000. And then this side will be left with minus A. So the value that will be left with this side will be minus 20,000 equals to minus A. So since we've got a minus A, we don't actually have a minus A, so meaning that we'll actually have to divide everything by negative 1. So once we divide everything by negative 1, we're going to have a positive A being equal to 20,000. So meaning that A is equal now to 20,000, meaning that the value of the amount that you actually went and that you did not manage to record within your business, it's equaling to 20,000. And you can try to look within to say that from all the things that I accounted for, what could be the possible thing that I did not account for that could be worth 20,000. Then it will be able to assist you to able to track down what was the account that you spent it on, and the value have to equal to 20,000. So meaning that from equation we move to formulas, and from formulas again, sometimes when we do this, when we try to solve a problem which is mathematics or business problem through formulas, sometimes we have to actually try to create a formula or rearrange, or I will say to manipulate the formula to suit this scenario. To say that if there are two values that are known and one is not known within the equation which have got three values, therefore we can make the value that is being required the subject of the formula, which is the next part. To say that if, for example, we do know the profit that we made, we do know the revenue that we generated, but we don't know the number of the cost of expense that we incurred. So we can make expense the subject of the formula by going and saying, let's leave expense to become the subject of the formula and the rest become an expression. So therefore, we're going to go and try to move revenue from this side to the other side and only be left with expenses as the subject of the formula. Previously on lesson number 3 or 2, we did the accounting equation. We also mentioned that under the accounting equation where you have got assets equals to owner's equity plus liability, if you know the value of your assets and you also know the value of your liability, you can calculate the value of owner's equity, which is similar as saying what? Your assets minus liability equals to owner's equity. So we have actually made the owner's equity the subject of the formula, since it's what we are currently looking for. So here it says that based on the principle, when changing the subject of the formula, so I'm just going to go back to the full screen view. It says that when changing the subject of the formula, we rearrange the formula so that we have a different subject. And to do this, the following have to be applied. If you move a term from one side of the equal sign to the other, change the operation. If it's addition, you change it to subtraction. And if it's divide, to multiply, vice versa. So we do the opposite. So if you take a look in terms of changing the subject of the formula, we are applying the principle of solving an equation, because a formula is an equation. So if you take a look at the first principle, so we are applying everything that we mentioned within solving an equation. And I just did explain that a formula is an equation which have been proven to become a fact. So here it says that the reason we apply those rules within our equation, they are called what we call an inverse. So we are doing the opposite. So they're called an inverse when we change the operation signs. To say that if it's multiplying, let's divide. If it's adding, let's subtract. So we are applying what we call an inverse. So here it says that, for example, if the term you want to move is adding, when you move it to the other side, it subtract. So here under formulas, they have actually summarized the whole process that we perform during solving an equation. So instead of you actually having to add on both sides, just take the amount, put it on the other side. But the first question you have to ask is to say, is it multiplying or adding, subtracting? Which operation is it performing? So if it is adding, therefore you subtract it on that side. So when you subtract it from everything that is on the other side. And if it is dividing, it divides everything that is on the other side. So let's take a look at the textbook in terms of page 128. So 128, changing the subject of the formula. So here we've got different types of formulas that have been presented within the textbook, which they are using different types of terminologies, science terminologies, technology terminologies, which have been used to actually try to show you how to change the subject of the formula. So here it says that if V is equals to IR, which is an equation and therefore proven to become a formula, where V represent electrical voltage and I represent electrical current and R represent the electrical resistance. So if we are to calculate the R, which is the electrical resistance, after measuring V and I, we can rearrange the formula as follows. So since we have got V multiplying equals to IR, so what we basically do under this equation is that We are trying to get R to be left alone on one side so that it can become the subject of the formula. So 1 to become subject of the formula, it have to stand alone within the whole equation. So before, if the equation looks like this, so V is now the subject of the formula, but now this time we want to make R. So when we make R subject of the formula, we take a look at the values within the right side where R is. So the only value that is there is I. So since it's I and I is multiplying R, so since they are written close to each other, so that means that they are multiplying each other. So we've got IR. So to cancel the multiplication, what we're gonna do is that we're gonna divide everything by R. Sorry, by I. So meaning that we're gonna divide everything by I and be left with V over I equals to R, and then we can write this in a more presentable way and go and say R equals to V over I. So we can be able to end up to this final answer that is being provided here. So any questions so far in terms of equations and formulas before I can introduce the new concept? Any questions? Guys, any questions? Are you all sorted? Can I see thumbs up if you are happy? Okay, thank you very much for the thumbs up. So the next concept that we are going to be covering is going to be the independent and dependent variable. So on the first equation, I only mentioned that there was one variable, but in some cases, there might be two variable or more. So what we're gonna learn today is that we're gonna only focus on two variables. So when there are two variables, most cases, we found that one variable depend on the other. So meaning that we're gonna end up having a dependent and an independent variable, where the dependent variable is the variable that will depend on other factors that will have positive influence on it or negative influence. And then we've got an independent variable. So independent variable does not get to be influenced by anything. It is the one that causes changes to the other variable. So independent variable in a business, I will measure it in the following way. To say that the more production, if we're running a production of any item, if we're producing a product, so the product becomes what you call the independent variable, and the cost of producing that product become what you call the dependent variable, meaning that if we don't produce any product, there won't be the dependent variable, which is the total cost. So meaning that there won't be any cost. But then again, the more the independent variable gets to be produced, which is going to be the product, therefore we're going to expect the total cost to be go up. So therefore that is the best example of independent and dependent variable. So under this lesson it says that, for example, time spent studying can cause change in the test score, but it is not possible that the test score could actually change the time that was spent studying. So that is just logic and common sense, which is being applied on the example to say that the more and harder you study, you'll actually get to score good marks. But your test score could not actually change the time that was spent on studying. But if you change the time spent on studying, you could actually change your what? Your test score. So the likelihood of you being able to score more marks is much better. So all of these independent and dependent variable lead us to what we call the linear equation. So they all lead up to the build-up called the linear equation. So in terms of the linear equation, so a linear equation is an equation that shows a relationship between two or more variables. And we've been doing this linear equation, I believe, since the high school era, where we get to work with an equation called y equals to mx plus c. So this linear equation is also referred as a simple regression in mathematics. And it does not just only get to be used in finance, it is used in all sectors. Whether you are in media, whether you are in whether you're in medical, whether you are in engineer, all of these they get to use the linear equation. So, but in media and finance, we use probabilities to estimate future cost. Doctors use the linear equation to estimate future probable cause of either an infection or your in terms of your health. They also use what we call the linear equation to say that the rate that your sickness is growing by, we expect it by 10 years time to actually be worse, or to say that you cannot live up to 10 years. It's because the medical system that was used, it's using what we call a simple regression if there are only two factors, which is your health and one virus. So that one virus will cause your health to go down, and if it's untreatable, they are going to calculate the rate at which that virus is actually growing, and then they get to use a linear equation to actually estimate when it's gonna be at its peak, to say that how big will it be in the next in terms of time, to say that in 5 days, 10 days, 50 days. Then if they are getting bigger value in terms of days, then they convert it to years, from years, from month to years, and then from years they can move it to decade, to say that you only have 20 years to actually get to live. So they are using what we call a linear equation. But in a business environment, we use linear equation to estimate future cost. So we've got y equals to mx plus c, where y will represent the the dependent variable, and then x is the independent variable whose value helps you to determine the corresponding value of y. And then m, it is the constant, being the coefficient of x. So since it is multiplying the unknown value, which is x. And then c represents the constant, which is either a fixed amount or a number. And then m, it also represents the slope of the straight line in an equation graph if we're to plot y equals to mx plus c. So y equals to mx plus c can be plotted, can either be like this, or sometimes we can find it to be like this. So the only way we can find it to be like this, it means that m is positive. And when we find it like this, m is negative. So the m is negative, this side the m is positive. So in a business, we'll never have an m that is a negative, we'll always have an m that is a positive. So it can either grow like this, where the points that you estimate in the future, they will be somewhere within this line, but the actual result will just fall somewhere in within. So this linear equation just allow us to estimate future costs that are mostly accurate or close to the amount that we are trying to figure out. So we've got these examples. If you want to see more in terms of linear equation, we'll have to go to page 131 up to 142. But I've tried to simplify the understanding by using a linear equation in a business, to say that let's apply the linear equation into a business to see how it gets to work. So in a business, we're going to be working with estimating future cost. To say that let's try to estimate future cost through the linear equation. So meaning that our equation y equals to mx plus c will therefore be given new terms, to say that y, which is the dependent, will become the total cost. So the total cost will depend on something which is x, where x will be the cost driver, or the number of activity being performed, which is going to become the independent variable. And we're going to look for our gradient, which is going to be the variable cost per unit. And then we're going to have C representing the fixed cost. So before I move forward, I'm going to explain these terminologies that are being used here. We've got the total cost. So total cost represents the total variable plus your fixed cost. So when you're producing something, so I'm just gonna go off from this. So when you're producing something, so let's just see. So when you get to produce something, so this is what's gonna normally happen. So your total cost, we are saying it's equals to your total variable cost plus total fixed cost. So you can just write total fixed cost. So that will give you your total variable cost, your total cost. So what is the total variable cost? So just a moment so that I can make sure that everything fits within here. So we are saying that your total cost is equals to total variable cost plus total fixed cost. So variable cost in manufacturing or in a business, these are costs associated with the manufacturing of a product or bringing the product into the business. So let's say, for example, let's start with manufacturing. So in terms of variable cost under manufacturing, that will be the cost of a material that was used to produce the product, plus the labor cost, plus the machine usage cost, which is gonna also form part of the electricity usage that was used to produce the product under that machine. So the machine cost won't count it because it was already bought, but the moment we use the machine, it's gonna give us electricity cost. So therefore, that cost, when I call it a machine cost, to say that this is how much we spend it on the machine for it to run by buying electricity. So you're going to have your machine cost, you're going to have your labor cost for people who are working to manufacture their product, and then you're going to have the material used cost. So all of those, they give you what we call the total variable cost. But a total variable cost for a product, for one product, remain constant, but for a lot of product the total variable cost will be not constant, will be changing, to say that we can actually calculate the variable cost per unit, to say that for us to produce 1 unit, it costs us, while the material that we use, it's cost us 10 rand for one product, and per labor hours we pay that person uh, 5 rand to produce one product per product, and then the machine to use it to produce one product, it costs us 1 rand electricity. So therefore in total our production, our variable cost, it's actually 16 rand. So therefore for each and every number of units that will be produced, we're going to multiply it with the variable cost per unit to get the total variable cost, which we're going to add it with the fixed cost, where now we come to the fixed cost. So fixed costs are those costs that remain constant no matter what. They will never change. So for example, building rental, whether you rent a building to produce product, even if you don't produce any product, the rent will still have to be paid. And then again, we have got salary of an administrator or a manager, whether products are being produced or not, or whether you are selling anything or not, those people will still have to be paid. So therefore that qualifies it as a fixed cost, and that cost will remain the same. And then again we've got water and electricity, that is related to usage by the administrator and the manager and other people within the business that are not involved in the manufacturing of a product. Any cost that is related to the manufacturing of the product or bringing the product to the business, we call it a variable cost, because that cost can change anytime. For example, if you're in retail and you are buying and selling, you buy and you sell. So the cost of you buying and bringing that item, including the transportation cost, will be your variable cost. So meaning that next time when you go buy, you might find the cost went up or down, and based on the number of units that you're gonna buy, the variable cost will be based on that. But there are rental, your building rental, your salaries of your other employees that are there to actually help you to sell those products are gonna be fixed. Whether those products have been sold, you still have to pay them. So that's what we call the fixed cost. So meaning that the full expression for this will become TC equals to VC open brackets X plus FC. So this will become what we call an equation or a formula that will be used to actually estimate future cost. To say that we're gonna first identify the variable cost per unit, which is easy to identify, and then later on we're gonna identify what we call the fixed cost. So here it says that one of the methods used to estimate cost using a linear equation is called the high and low method. But before I explain the high and low method, I would like to hear from you guys if you have got any questions so far. Any questions? I've just explained some new terminologies that you are not aware of. Any question? Guys, any question? Okay, I say you're all good. So let's continue with our session or our class. So when you're dealing with the linear equation in a business, so here it says that for us to be able to estimate using that same equation, which is the high and low. So I'm just gonna put this because there's something that I want to draw first before I go to the real drawing, so that you get to understand why we are using that. Why is the high and low method developed, and how was it proven, or how does it exist? So with the high and low method, it says that the high and low method is a method of estimating cost by comparing the total cost associated with two different levels of output. So the difference in the cost is assumed to be caused by the variable cost increasing and allowing unit variable cost to be calculated. Following from this, since the total cost is known, the fixed cost can be calculated. So I'm just gonna try and draw a diagram while explaining this concept. So we're gonna be having something that looks like this. So this will be your Y and this will be your X. So what I am saying is that from your Y, we said that your Y will become your total cost. So Y will represent total cost, and we say X is the independent driver. So meaning that the total cost will depend on the number of units produced or number of activity performed. So meaning that here we're gonna say this will be the units. And then we are saying that based on the formula that we covered this side, we said now the formula will say total cost equals to variable cost multiplied by the number of units produced plus the fixed cost. We said the fixed cost remain the same. So meaning that, sorry about that. So meaning that when there is no product being produced here, which is gonna be at 0 here, we're just only gonna have one type of cost, which is gonna be the fixed cost. So this cost will remain the same. It won't change at all. So even if the production is at 0, this cost will remain the same. Whether we run the company, this cost will be there because we have to pay the rent and all the employees. And then the moment one unit is produced, the total cost is gonna go up. And when it goes up, the difference from the fixed cost to the total cost, which will be here, will be caused by this small gap, which is the variable cost. So meaning that now a unit has been produced, we incurred a specific cost. So therefore now our total cost is now sitting here. And then when more units are being produced, this cost will actually go up. To say now we've got 4 units. So when 4 units are being produced, already fixed cost will be already incurred. but the cost will go up somewhere here, meaning that the difference from the fixed cost up to the total cost, which will be somewhere here, will be caused by the variable cost. So will be caused by the variable cost. So meaning that the gap between the fixed cost and the total cost line, this gap in between, will be what we call the total variable cost. So guys, are you still following? Please, I don't want to lose you on this. So are you still following? So I believe we are still following. So what is actually happening is to say that once you have a fixed cost, the more the units start to be produced, your total cost line will start to exist, because now more units are being produced. So the total cost will become your variable cost plus your fixed cost. So this all space represents your variable cost, and this line represents your total cost, which will be the addition of this from this point to here will be your variable cost, and therefore when you add all of them together you get your total cost. So in a simpler version, applying the high and low method, it's explained with the following diagram, to say that you're gonna have the lowest activity that was performed, which is the lowest cost, the lowest activity, and then you're gonna have the highest activity. So we do know that if you produce 1 unit and you produce 10 units, the cost of producing both of these units will be different. So we're gonna assume that this will be your lowest, or this will be your lowest, and this will be your highest. And this line here is your what we call your fixed cost. So it represents that cost that will not change no matter what. So even if the production is 0 here, this cost will be there. So total cost will be equal to fixed cost, because variable cost will be 0. But the moment we produce something here under low, let's say this is 10. So the moment we produce something here, from the fixed cost, this all portion going up, this will be our variable cost, and then this will become the total cost. So the total cost will be the variable cost plus the fixed cost, so therefore giving us the total cost. And for the highest, we are saying that you're gonna have your highest here, and then from your highest activity you're gonna have your highest cost, and then the gap again from the fixed cost going up to the total cost will be caused by the variable cost based on the high number of units produced. So the difference between the two costs will only be caused by the changes in the number of activity level, because the fixed cost will still be there, but again this cost surpassed this one because of the increase in the activity by this gap here, which is represented by A, this only gap. So that will be the gap that represent the changes, so which is the variable cost, because the fixed cost here is still the same, but here we've got a slight increase. So that slight increase, which is A, it's only caused by the variable cost because more units were produced. So this allows us now to use what we call the high and low method, which says that under the high and low method, you're gonna select the period with the highest volume and the period with the lowest volume of activity, and then from there you're gonna calculate the difference between the total cost and the difference divided by the difference between the activity level. All of this will actually give you what we call the variable cost per unit, because we are saying that the cost from this total cost here to this total cost here, we know that the fixed cost on both is the same, but the variable cost will not be the same because it's based on number of units produced, and here we've got higher units produced, here we've got low. So meaning that the difference between the two is actually the variable cost. So therefore meaning that if we know that the difference between the two costs is variable cost, if we divide it by the number of units the difference in the number of units, we can actually get the variable cost per unit. So the formula to now calculate the variable cost per unit could be as follows. To say it will be the total cost of at high level of activity minus the total cost at lowest level of activity divided by the total unit at high level of activity minus total unit at lowest level of activity. In summary, we could just say the difference in the cost of high and low activity and the difference in the activity which is high and low, and therefore this will give us what we call the variable cost per unit, which is our M. So guys, are you still following? Guys, are you still following? Okay, let's continue. So this will be the variable cost. Thank you for the confirmation. So when we move now, we're gonna try and do what we call an activity. So this is an activity that I'm going to show you how to actually work that out. From this activity, you guys are we're gonna try a question together. From there, we're gonna be done with the lesson. So this is the most important part. So here it says that a linear equation in a business, DG company has recorded the following total cost during the last 5 years. So they've been recording all their cost for the past 5 years and their number of banners being produced. So they are tired of actually just incurring cost over the years. So what they actually get to do is that they are trying to identify what will be the future cost for 2023 if we are going to produce 85,000 banners. So the most important or difficult task within this activity is to identify which one is the dependent variable and which one is the independent. So if you have got a total cost, the total cost always is your Y, and the number of units or activity being performed will be your X. So what is left for you to find is your M, which is also what? Your VC, variable cost per unit. And then once you have that, you can find the FC, which is your fixed cost. So we're going to apply this, and when we're applying this, we are still going to be applying the same formula. TC equals to VC. Sorry about that. So it's supposed to say VC since we're trying to estimate future cost. So it's going to be VC X on brackets. We're going to have our X plus FC. So based on the high and low method, so there are stages that we actually perform to actually get to calculate or to write down the equation. So this equation, we need to find the value of FC for VC and the value for FC. Once we have got these two values, we know that the total value, which is the variable cost represented by this, will normally be changing based on the number of units being produced, and then we add it with the fixed cost to get the total cost. So based on this activity, the first step is to identify the highest cost, then identify the highest activity followed by the lowest activity. You do not identify the cost, but you identify the activity. Which one is the lowest activity, which one is the highest activity? Guys, this one I want us to do it together so that we are both following and we can actually get to understand the concept. So let's start. Let's start, guys. So the first step, identify the lowest activity and the highest. Which one is the lowest activity? Which year is the lowest? Which one is the highest? Okay, 2021 have got the lowest, and which one have the highest? I'm reading a chat section that someone sent. They have identified the highest, and the highest is 2020, where we've got 90,000 units. So once you identify the higher, the lowest and the highest, the second step is for you to pick up their cost, to say that okay, for 2021, which is the lowest, its total cost is 140, and for 2020, which is the highest, its total cost is 170,000. So we're gonna come this side. Let me just quickly change this. I noticed that there is an error here. So that was step one, identifying the lowest activity and the highest activity. From that, we then go and identify we go to step two. Step two is to pick up the total cost for the lowest activity and the total cost for the highest activity. So these were all given. So for highest activity of 90,000, we just label it down, and then the highest cost of that is 170. And for lowest activity, which can having 60,000, its total cost is 140. So we did mention previously that the difference between the total cost, it's not caused by the fixed cost, but it is caused by what we call the variable cost. So meaning that the difference between these two costs is the variable cost. So meaning that to get the variable cost, the total variable cost, it will be the difference between the total cost, which is going to be 170 divided by, sorry, minus 140. So we're going to have 30,000. So for me to do this, I think I still have to go back to the typing so that we do this together. So we're saying now for you to be able to calculate total VC, which is the variable cost, it will be 170,000 minus 140,000. So all of this will be equals to 30,000. So meaning that the difference in the two costs, based on our example and the slide, we are saying that it is caused by the variable cost because it's the one that is going up and down based on the changes in the activity level, which is the number of units being produced. So meaning that if this is caused by the changes in the activity level, we can actually identify what we call the variable cost per unit, which the variable cost per unit will be the total value, will be the variable cost divided by number of units which caused the changes. So will be the difference again within the number of units which caused the changes. So meaning that under this case, we're going to have it being equals to 30,000 divided by the number of units that cause the changes, which is 90 divided minus 60. So meaning that the units that cause all of this change is 30,000 units. So meaning that now our variable costs per unit will equal to 1 rand. So this will become the variable cost. So meaning that for each and every unit that we produce, we pay 1 rand. For every banner that this company produce, we get to pay 1 rand. And from there we can apply step 4. So this is the summary of this step that is on the right side, which is step 3. So it's an explanation of the variable cost per unit, which is step 3. Since we are saying that the difference in this cost is caused by the variable cost, so the difference in this cost is caused by the total variable cost of 30,000, which this variable cost is being caused by the increase in the number of units of 30,000. So therefore, the variable cost per unit is actually how much? 1 rand. So now we have got our formula TC. So now I've got our formula TC equals to VC, open bracket X, close bracket plus FC. So we can now write this formula to say that TC is equals to 1 rand X. 1 rand X plus FC. So from this point forward, that's when we can be able to say that since now we already know our variable cost per unit, based on the information that we pinpointed from our information, where we have got the lowest activity being 60,000 and the highest being 90,000. Let's use one of those points to actually calculate the fixed cost, because the fixed cost is already found. So what we are doing now, we are saying let's make fixed cost the subject of the formula so that we can be able to find its value. So everything that I just started with, which is the equation, then formulas and changing the subject of the formulas, they all lead to all of this activity. So meaning that now we want to try to find fixed cost. So fixed cost, if we were to write it, will be equal to total cost minus 1 rand X or 1x, where the x represent what? So let me just put it in bracket, where the x represent the variable, the independent driver, which is the number of units. So we just moved this to the other side. So since it's positive, when we move it that side, it's gonna be negative. So we're gonna have TC minus 1 rand X plus equals to FC. So therefore, when I rewrite it, it's gonna say FC equals to TC minus 1 rand X. So meaning that we can use any of these points to actually calculate the fixed cost, because those points have got what we call the total cost. They also have the number of units that were produced. So meaning that the fixed cost will be easy to actually get to identify. So let's start by using the lowest activity. So if we're to use the lowest activity, fixed cost will actually equals to lowest activity total cost is 140,000 minus the 1 rand, open bracket X. So X represents the number of units that were produced. So that will be the number of the lowest activity, which is 60,000. So meaning that now we're going to be having 140,000 minus 1 multiplied by 60,000, 1 rand multiplied by 60,000 units. So meaning that we paid 60,000. And then from there we're going to say 140 minus 60,000. That will give us the fixed cost being 80,000. So now we've got a value of a fixed cost becoming 80,000. So once we have got the value of the fixed cost, it means that we can go and write our equation to say that the total cost is equals to 1 rand, which is the variable cost, multiplied by X plus 80,000. So you can prove this by substituting 80,000 within here to say that we've got 1 rand. Sorry, we've got 1 rand. And say, let's put 90,000 in it and see if we're gonna get 170. So we're gonna go and say if we produce 90,000 units plus 80, it equals to, so here it's gonna give you 90,000, so that will be 1 rand multiplied by 90,000 units plus 80,000. So when you add all of this together, they will end up giving you 170,000. So meaning that now you have got an equation which says that to estimate total cost will be equals to 1 rand X plus 80,000, which is the fixed cost. So you can still use different points here to say that let's use the highest point. So if we use highest point, number of units was 90, so here it's gonna be saying 90, and then here the number of units, just a moment. So here we're saying that the number of units will be 90 and the total cost will be 170. So meaning that if we go and try to solve for FC using the highest activity and highest cost, we're gonna have 170 here, and then here we're gonna have 1 rand multiplied by 90, which is gonna give us 90,000. So we're gonna end up having 170 minus 90,000 giving us 80,000. So meaning that we're gonna still be coming back to the same fixed cost of 80,000. And you can still prove this by adding using the other one that you did not use, which is the lowest activity, and it have to give you the lowest activity total cost. So now that you have got this equation, I'm just gonna go back. You can now be able to estimate the new future cost of 85,000. But remember, do not try to estimate the ones that are already here, which is 65. What is going to happen is that it's going to give you a number that is close to 145. This already happened. So when you estimate, you are trying to find a figure that could be possible. So if we go on our equation and use 75, if we come here and say we are using 75, so that means that here it's going to become 75,000 plus 80,000. So that will give us 155. So that will give us 155, meaning that in the future we expect the future amount to be plus or minus 155,000. If you still remember the accuracy of approximation where we get to estimate plus or minus. So this future estimation cost, this is what it gives us. So if we go back to real result, you will see that it's 160,000. So we are not far away by 5,000 because we're working with thousands value. So therefore the difference have to be the difference will not be that much if we're looking in terms of the values that we're working with. So meaning that even if we try to change this, so meaning that in the future we expect the cost to be somewhere here plus or minus 155. So we don't expect it to be 70,000, we don't expect it to be 200,000, but we expect it to be close to 155,000. So to say that if we are to estimate 85,000 units, the cost have to be in between. If we check 80,000, it's 162. And if we check 90,000, it's 170. So meaning that our future cost have to be between 162 to 170. So let's just try that out. So we are saying that X will become 185 in the future. So when we estimate, so meaning that here we're going to have 85. So meaning that when we try to add this, we're going to have variable cost being 1 rand multiplied by 85,000 giving us 85,000. 85,000 units giving us 85,000 plus 80,000, so that will be 165. So meaning that we expect the future cost to be between 160 plus or minus 165. And based on past data, we can see that if we're to check 65, if we're to check 80,000 and 90,000, 165 falls in between 162 and 170. So meaning that we'll expect it to fall somewhere in between here. But it can still be 162 in the future because this cost could actually get to change in the future. So this is the rest of the solution to say that step 4, if y equals to tc equals to, therefore tc equals to vx, then we look for fc by making it subject of the formula, since we know the value of the variable cost and the total cost as well as the number of activity being performed. So this is the work example that I was busy showing you. So guys, I'm gonna give you 15 minutes. 15 minutes by quarter to, okay, 10 minutes. By quarter two, I want you to identify me the total cost model for the period that could represent the following information. It says that a broadcasting department of a large media firm wishes to develop a method of predicting its total cost in a period. The following past costs have been recorded with the following two activity to say that we have got numbers of viewers here, where the numbers of viewers are the ones that influence the total cost. So we had 420 from January to March, which the total cost was 82,200. And then in April to June, we've got 515 viewers. And then the total cost was 90,000 using these two type of cost. So you're going to identify which one is the lowest activity, which one is the highest. And then you're going to draft a costing model for me that will be used to actually estimate future cost. So, and you're gonna pick up, so there is already option here in below. So 10 minutes by 46, I expect you guys to be done. So please write this down. I'm giving you 10 minutes to do so. And please write it down so that you can be able to explain it to me how you manage to pick number C, number B, number A, or number D. 10 minutes. Eight minutes remaining. 6 minutes remaining, guys, and then we can do the solution. Okay, 4 minutes. Whoever likes to attempt it first, can we see a raise of hand? Anyone who likes to attempt? Two minutes almost remaining. I'm still waiting for a raise of a hand from someone who would like to attempt this question. Okay, a few seconds remaining. And we are done. Okay, who would like to attempt it first? Let me see. To me, what is your final answer? What did you get as a variable cost per unit? To me, what did you get as a variable cost per unit? To me, to me. Okay, to me is not answering. CBC.
So I'm still working it out, but I got 85 so far. I'm still working on the fixed cost, I think.
So you got 85.
Yes.
And Neo, how much did you get? Neo? Neo, are you there? Okay, CBC, you're 100% correct. So now I just want you to take a guess. We've got A and C, both have got 85. So which one do you believe is correct? CBC, which one do you believe is correct?
I think A.
Why A?
I don't really know it.
Okay, let me assist you. So what's actually happening now from this scenario? The first thing that we should have picked up, the formula or the costing model does not have any negative on it. So meaning that these two are already out of the equation. So we cannot use them because they are saying minus. And if you remember back then on our formula, y equals to tx, it says everything here is positive. So if you check everything here, it's positive. There is nothing that is negative. Even if we start by FC, which they did there to say FC minus Vx. So still everything will still be positive because it will be FC plus Vx, not FC minus. So nothing here is negative. So total cost, if they just only swap these two around, which I believe it is one of the law that we did mention earlier on during our lesson, that you can still start with any as long as you do not change any of their sign. So both everything is positive, so meaning that under this equation, TC will not have minus 85x or minus 95. So it's totally out. So what is left for you is to actually calculate the variable cost. So once you calculate the variable cost and find it to be 85, so this leaves you as the right answer. So the only thing that you just have to confirm is to calculate the fixed cost since you are choosing multiple choice. But here we have got a solution that will help you to do that. Say variable cost is the difference in cost over difference in activity, which the activity will be the viewers. The more we have got viewers, the more this cost goes up. So therefore activity will be based on viewers. So we're gonna go and calculate the difference in that, which is going to be 90,275 minus 82,200, and then again we're gonna have the difference in the viewers, which is 515 divided minus what, 420. So all of this will give us the following difference: 80,775 and 95 viewers. So in total, you're gonna use this to calculate the variable cost per viewer, which is going to be 85 rand. So meaning that one viewer will cost you 85 rand, and then the more they come, the more the viewer are there, the more the cost will go up. So this is the variable cost per unit. So to find the fixed cost, previously I showed you how to actually calculate that, which is calculating the viewers, calculating the fixed cost, which is making fixed cost subject of the formula. So here it's gonna be a multiplication sign. Sorry about the question mark. So it's gonna be so we're gonna use the highest, which is 515, and then its cost is 90,275. So we're gonna replace the total cost with 90,000. We're gonna put x as 15 and multiply it with uh, 85,000. So therefore fixed cost will be equals to the total cost of 90,000 minus the variable cost, total variable cost. This will give us the total what? Fixed cost being 46,500. So what I want you guys to do is this. I want you to use 420, 8,200 on your spare time, and then try to find the 46,500 to make sure that your answers are 100% correct. So here it says that by understanding that you know the TC formula, you should have managed to eliminate C and D as incorrect option straight away because of using the negative sign within the formula for TC. So once you see the TC equals to and you see a negative sign, that is totally out. And then the second thing is that the variable cost must be added to the fixed cost rather than being subtracted from it. So once you had calculated the variable cost of 85,000 for viewers as shown above, you should now be able to calculate the fixed cost using the TC formula by rearranging it and making fixed cost the subject of the formula. So that is it in terms of today's lesson. So next week we're gonna be covering what we call graphical illustration, where I'm gonna be talking about different types of graphs and how they're important and how we get to use them in a media environment. And then we're gonna also do some class activities as well on Friday, which they're gonna be showing us how important is graphical illustration in a business environment, especially you guys in media. You work with data a lot, so you're gonna be working with data almost every day, so you need to understand how to present which type of data under which type of format or graph illustration. So that will be it for next week. So please make sure that you go through all this lesson, including the activities that are on the book that I also mentioned, and then at the end try to solve try to come here to this um, simple question that gets to assess to you to say that did you manage to understand everything that was being covered in this lesson? Do you understand the activities? If yes, then we can move with us on Friday and do lesson 12. So any question on what we covered so far today, or everything that we covered on lesson 11? Any question, guys? Any questions? You are the guys that are remaining here. So any questions? Okay, in absence of questions, so that will be all for today's lesson. We shall meet on Friday. Someone is asking, where do we get 95,000? This is a wrong. So you are supposed to choose between A, B, C, and D. So this is completely wrong. So when you're trying to choose here, you have to solve and find the variable cost per unit, which is 85. And then you're going to also find the fixed cost being 46,500. So meaning that the correct equation or costing model for each and every period that you can be used to estimate future cost, it's number A. So we get to use number A as our costing model, and therefore these all three now becomes wrong. So I said we already eliminate the first two because of the negatives. They are subtracting the variable cost, which is not what the formula says, and then we start to look for A and B. Either one of the two is correct, which we identify that A was correct. So this is incorrect. Did I manage to help you, Tumi?
Yeah.
Yes, CBC?
For the first example, you used the 60,000 for the units,
Yes.
which is the lowest.
Yes.
So now for this example, why did we use the 515 viewers? That's the highest.
No, I did mention that you can use any, either the lowest or the highest. Your answer will still be the same.
Oh, okay.
So what you can do is that on your side, try to use the lowest and see if you get the 46,500. That I can guarantee you that it will become as 46,500.
All right.
Any other question? Comment? All right, that is it. That is the end of our lesson. You'll enjoy the rest of your day. We shall meet on Friday. Thank you very much.